Good afternoon, everyone. So I am Silva. I'm from the State University of Santa Catarina in Brazil, and together with my friend Dr. Cassiano Velker from the Federal University of Uberlândia, also in Brazil, we are organizing this symposium that is titled Advances in the Taxonomy and Phylogeny of Panicoideae. So the grass family currently includes 12 subfamilies, and these 12 subfamilies, there are 3 here that form a basal grade, and the remaining subfamilies are distributed in 2 large clades, the bob clade here with Bambusoideae, Oryzoideae, and Poaceae, and the Pac-Med clade where Panicoideae is. So the Panicoideae subfamily currently includes about 242 genera and 3,325 species. This subfamily includes important crops like maize and sugarcane, and also some species that are highly available as forage, like the genus Paspaleae, for example, or Brachiaria. Well, if we look here at the phylogeny of Panicoideae, we see that this subfamily includes 14 tribes, and these 14 tribes are distributed in 2 large clades here. This clade includes what we call the basal panicoids, and the other clade here are the core panicoids. In core panicoids, we have tribe Genera, Lecomtelleae, Paniceae, Paspaleae, Arundinelli, Andropogoni, and the recently proposed Jansenelli. And the only synapomorphy that the subfamily has, as said by Sanchez, Ken, and Clark in 2010, are the overlapping embryonic leaf blade margins. So that's it. I'm going to move to my talk, the first talk of this symposium, that is titled Impacts of Molecular Phylogenetics on Genetic Classification in Paniceae and Paspaleae. I prepared this presentation in collaboration with Dr. Fernando Zuloaga from the Instituto de Botânica Darwinio in Argentina. So, why talk about this topic? We as taxonomists, we know that classification has been based mainly on morphology, but morphology can be tricky. If I show these 2 pictures to a person who's not a botanist, this person probably would say that both plants here are cacti, but we as botanists, we know that this is not true. So, if we look at the angiosperm phylogeny tree, we can see that the plant at the left actually is an euphorbia that belongs to the Malpighiales clade here. And the other plant is actually a cacti from the genus Opuntia. So the cacti belong to Caryophyllales, and we see here that they are distantly related. So euphorbias are more related to beans or cocoa, for example. So when we only use morphology, we can produce classifications that are biased. So we need to combine morphology and molecular data to evaluate the classifications we have. So that's the reason why I'm talking about the impacts of molecular phylogenetics on genetic classification. So my starting point here will be the General Graminan book, because this was the last major classification that included only morphology. So in this book here, Clayton and Renvoize, they treated subfamily Panicoideae, including 7 tribes. And these 7 tribes were Paniceae, Zacni, Hubari, Eriacni, Stereomarchocloe, Arundinelli, and Andropogoni. And in this classification here, Paspaleae was included in the synonymy of tribe Paniceae. So at that time, Paniceae had 101 genera, approximately 2,000 species, mainly distributed across the tropics. And later, only 6 new genera were based only on morphology. So what characterizes tribe Paniceae? Tribe Paniceae is characterized by plants possessing 2 flower spikelets, and these 2 flower spikelets, they possess 2 glooms at the base and 2 florets above. And the lower floret is male or sterile, while the upper floret is bisexual and indurate when fertilized. So Clayton and Renvoize, they had the insights on the relationships within the grass family. And if we look here what they said about the panicoids, we see that they proposed that Paniceae would be related to Eriacni, Hubari, Zacni, Stereomarchocloe, and these would form a clade that is sister to Andropogoni plus Arundinelli. But now we know that 3 of these tribes here actually belong to another subfamily Micromorphological. And I also show you that Panicoideae currently includes more tribes, and the relationships are different from those here. Well, now let me talk a bit about the changes at the tribal level that are related to Paniceae and Paspaleae before going to the generic classification. So, in the beginning of the 21st century, Gomez, Martinez, and Curran published a phylogeny based on placid data on Turnell F, and later Giussani and collaborators in 2001 published another phylogeny based on placid data, but based on the NDHF gene. And in this study here, the last one, we can see that tribe Paniceae was recovered in 2 distinct clades. One of these clades including pantropical taxa with a basic chromosome number equal to 9, and another clade including American taxa with a basic chromosome number equal to 10. And the problem here is that this clade, X equal to 10, is sister to the clade including Arundinelli and Andropogoni. So here we can see that Paniceae, as circumscribed by Clayton and Renvoize, paraphyletic. So more than 10 years later, Mahoney and collaborators, they expanded this phylogeny to include more taxa. So they sampled 265 taxa, and what they got was the same. So the relationships were equal, 2 clades, X equal to 9, X equal to 10. So based on that, they reinstated the tribe Paspaleae. So from this time on, tribe Paspaleae and Paniceae were segregated. One extra change, and here we can see also that we have a problem around this surrounding this classification, because the only character that were indicated as synapomorphies for these tribes were chromosome numbers. So we can't pick a grass and say, oh, this belongs to Paniceae or this belongs to Paspaleae. We can't, because there are no obvious morphological features that characterize them. And also, we see here in this ancestral state reconstruction that the characters of the spikelet and the inflorescences are highly variable, and they evolve multiple times during the evolution of these tribes. So, well, it's complicated. And another change at the tribal level is about the genus Lecomtelleae, an endemic bamboo-like grass, very strange one, that was placed in Paniceae earlier. And Besnard and collaborators published in 2013 this study based on NGS, where they show that Lecomtelleae comprises a monotypic lineage that is sister to the clade including Paspaleae and Andropogoni plus Arundinelli, here represented by Sakari. So based on this, tribe Lecomtelleae was reinstated. So it reaches where we are now. So talking about the changes at the generic level, I'm going to start talking about the non-monophyletic genera and the splits and lumps. So 30 new genera were split since genera Graminon. You can see here that the list is long. I'm going to exemplify that by talking about Echinanthus and Echinolina that were genera that I studied during my master's. So Echinanthus used to be a genus highly variable in vegetative and reproductive characters that included species with paniculate inflorescences, and the diagnostic character was the presence of hachil appendages in the shape of rings, scars, or convex swelling at the base of the upper floret. And Echinolina also was a genus that highly variable in both vegetative and reproductive characters, and the inflorescences in this genus was from paniculate inflorescences to partially racemized to totally racemized inflorescences, and the diagnostic character of Echinolina was the same of Echinanthus. This genus used to have species with wings, scars, and convex swelling. So it led us to think that this genera could not be monophyletic. So we test this through using molecular data. We use placid and nuclear regions to test this, and we performed a phylogenetic analysis that show that these genera, both genera, they were polyphyletic. And the species of them were recovered in 4 distinct clades. So based on that, we recircumscribed Echinanthus to include only species with wings, and we also recircumscribed Echinolina to include species with long scars and inflorescences with a single unilateral raceme. And The species here in this blue clade were transferred to a new genus called Eudea with short scars, and the species here in the clade in green were transferred to Eudocloa, possessing convex swellings at the base of the upper floret. So, I also would like to highlight that 22 of the 30 genera that were segregated since genera Graminon were from Panicum. So, Panicum is really a mess. Panicum is frightening. So, if we look at Zuloaga's classification published in 1987, Zuloaga divided Panicum into 6 subgenera and several sections. And when we analyze today, we see that these subgenera and sections do not exist anymore. So they were all transferred to new genera here. And also there were some species of Panicum sensulato as inserted series that were transferred recently to other genera like Nidocloa, Genocloa, Batocloa, or Stolonocloa. And what will remain as Panicum? Panicum sensu-strictum will be restricted to Panicum subgenus Panicum. So we see here in this phylogeny published by Zuloaga and collaborators in 2018 that the Panicum species comprise this large clade here within subtribe Paniceae that is sister to the genus Louisiella. So, true Panicum, let's talk about morphology. So true Panicum species with lax and open inflorescences, spikelets with 2 glooms, the upper gloom and the lower lemma 7 to 11 nerved, and the upper floret, indurate and shiny at maturity, and also all species C4 of the subtype NAD-ME. We have one problem. The genera segregated from Panicum, some of them are very similar to each other. So if we go to the field and we find these grasses here, we would say, oh, Panicum. But this one here is Lecomtelleae, this one here is Parodiophyllocloa. So we can't tell that, oh, no, this genus is this genus is that. We usually identify the species first, and then we look where this species is now. So it's complicated. And also, there were some synonymizations since genera Graminon 23. I highlight here this taxa with asterisks because these changes were not based on molecular data. Maybe they need to be better investigated. I will exemplify here the synonymizations by the case involving Penicetum, Cenchrus, and the Odontelytrum. So these 3 genera here, as you can see, they possess bristles accompanying the spikelets. So Odontelytrum used to be a monotypic genus with a spike-like inflorescence, surrounded by an involucre of a single bristle and a lobed structure. Penicetum used to include species with a lot of bristles of setose consistence, and Cenchrus used to be a genus with spiny bristles. When Chemistry et al. Published their phylogeny in 2010, they used plastid and also nuclear data, and what we see here is that this clade here includes the species of Penicetum, and Odontelytrum and Cenchrus were recovered nested within it. So clearly, Penicetum was paraphyletic, and then these 3 genera were merged in one, and the Cenchrus is the genus that we now accept because it's the oldest. We also have some reestablishments since genera Graminon. 7 genera were reestablished. I'm going to exemplify this by Echinolina and Chasiclo that I also studied during my PhD. So as I said, Echinolina was found to be polyphyletic, so I recircumscribed it to include only 2 species with the single unilateral raceme, and the remaining species were transferred to Eudocloa. I did that in 2015 with my advisor and other colleagues, and these 2 genera here are endemic to the Neotropical region. But in 2015, we could not assess 2 species of Echinolina endemic to Madagascar. So these species were kept as inserted series, and we only analyzed the phylogenetic relationships of them within the tribes Paniceae and Paspaleae in a subsequent study published in 2017 in collaboration with Guillaume Besnard, Beth van Silva, and other colleagues. So we use data from NGS plus Sanger sequencing, and what we got was that the Malagasy species of Echinolina were recovered here in this clade in red within tribe Paniceae, subtribe Boivinellini. Whereas the species of Echinolina here and Eudocloa belongs to a different tribe. So it was very surprising for us. Why? Because of the morphology of these plants. If we look at the inflorescences, they are very similar, and also the spikelets are similar. So based on this, we reestablished the genus Chasicloa for the Malagasy taxa, and this exemplifies one of the reestablishments. 68 of those genera from genera Graminon remain unaltered since then. But I would like to emphasize that it doesn't mean that they are monophyletic. It only means that they were not tested yet, or they were tested, but they are monophyletic. I will exemplify this with the case of Eriocloa. Eriocloa is a genus characterized by these cup-like structures here at the base of the spikelets, and Salariato and collaborators in 2010 published this study based on plastic data in which they tested the species of Eriocloa. So we see here that the species of Eriocloa were recovered in different positions within subtribe Melinidini, nested with other genera like Monocloa, Tricolena, Urocloa, Brachiaria, and so on. So we can see that this genus was not changed, but it's polyphyletic and it needs to be recircumscribed. And what is left to be done? So we still have some issues to solve. So in Paniceae, we have some problems to solve. In the Saxioleps rex clade, it includes the problem with the species of Saxioleps plus Panicum bisulcarum. Also, some insecticides of Panicum without a definite morphological unit. So groups of species, Panicum milligrana, Celovium, Tricoides, those here are very common here, for example, in Brazil. Panicum barleti, Tricanthum, Irtum, Glandul paniculatum, Pseudoracemosum, and so on. In subtribe Boivinaline, the biggest problem is Acroceres, that is polyphyletic. And also there are several species of C3 Brachiaria that needs to be reassigned, as well as some C3 species of Panicum from the Old World. They also need to be removed from Panicum and reallocated in other genera, new or existing genera. We have this problem here with Eriocloa in subtribe Melinidini, Eriocloa, Brachiaria, and Urocloa that needs to be solved. And also in subtribe Cencrini, we have this problem with Setaria that is polyphyletic too. In tribe Paspaleae, fortunately, there are no major issues to be solved, at least regarding the genetic classification, of course. So to conclude, my take-home message is that the changes will continue to be made until each genus becomes monophyletic. But we have some challenges to achieve this goal. One of those challenges is the difficulty in secure funding for molecular studies, especially when you say that your study is going to be for taxonomic purposes. So people don't get money, don't send us money anymore to perform those kind of studies, especially in Brazil. We also still have high costs associated with generating genomic data. Some people say, oh no, it's very cheap now, but it's not that cheap. So, and we also think about NGS in studies involving higher taxa when you sample only one species or another species. If you look at the generic level and sample several species, you need to include several species, so it would become even more expensive. And we also need to increase taxon sampling for most genera. Some of them were only tested with a single species. So we need to increase taxon sampling. And also, we have some problems that are inherent to the evolutionary history of some genera. Some genera have problems that includes hybridization, incomplete lineage sorting, that when we are doing the phylogenetic studies, usually it causes a lot of headache because we have different positions of the taxa and we need to make decisions. It's not always easy. And also, I forgot to mention that we have a problem with the young people. So young researchers don't want to do taxonomy anymore. So it's each time harder to find new people to study taxonomy. So we all here love taxonomy, of course. So that's it. Thank you all. I would like to say that I'm very happy to be here and that this moment here means a lot to me. So thank you.
Thank you very much. Yeah, now it's time for questions.
Sharp.
Hi, great talk. I just
Thank you.
wanted to say, so my colleague Lizo Masters published, I think, last week or the week before, reorganizing some of Brachiaria and Eurocloa using phylogenetics. So that might be some progress in that area, at least. Might be a good one to look out for.
Very nice to hear it. Zuloaga told me that this group still needs a lot of work.
It probably does. Yeah, I think they all do.
Yeah, a lot of hybridization. Yeah, thank you.
Another question?
Hi, great talk.
Oh,
Can
thanks.
you elaborate a little bit about the overlapping leaf blade margins that you?
I can't. I'm sorry. Lynn, please help me. You were the one who proposed the embryonic.
Looking at that, or?
We took the data from the literature to get that. And so anything that was scored for the embryonic character had overlapping leaf margins. So absolutely, that's one of those things that should be tested.
But I think it's also present in other subfamilies, right? In
There's a couple of
Poaceae.
others, but yeah, it's almost really a combination of embryonic characters.
Okay.
But yeah, we don't know nearly enough about embryos and things like that. So.
And it's not an evident character, right? Yeah. Cryptical one.
Another question? No, it seems like that.
Thank you
very much.